This video is a quick explanation of reflection, which is the word for chapter 11.2. We just in the last video discussed translation, which is when an item gets moved around from one place to another, but doesn't get changed in any way. Reflection is a little different than that. Here we have two items that reflect each other perfectly. This item, if you were to flip it over, would land exactly on this item, for example. Now, reflection needs a line of reflection. So in this case, I've put these two boxes apart. So I'm going to put a line down the center line, and you can see this is a line of reflection. So a line of reflection kind of acts like a mirror. You can imagine where the line of reflection is where the mirror is. That's a line of reflection. Reflection lines don't have to be up and down. They could be side to side. You could have this here, and then we would reflect over the x-axis, it's being the x-axis, and you'd wind up here. Notice that the pieces need to be exactly the same distance away from each other, or away from the x-axis, for it to be a reflection. In other words, if this is reflected over the x-axis, it's 2 units away here. While this looks like a reflection, it's not reflected over the x-axis. It's reflected over a line exactly halfway between these 2 points, which is not the x-axis. So, for example, and by the way, these figures could be lots of different directions and still be reflections as long as they both line up the same way. Those would still be reflections of each other, a little more complicated than a minute ago, but still reflections as long as their height is exactly the same and their distance away from the line of reflection is exactly the same. All right, so let's take a look at, I don't know, let's look at a triangle and reflect it. Let's reflect triangle that looks like this. Across the y-axis. So this point is 2 points away from the y-axis, so we need to be 2 points away from the y-axis, but on the same x-axis. This point is 4 points away from the y-axis, so we're going to go over here 2 more points. So this is a length of 2. We're doing a length of 2 here. And then we're going up 3 units and still staying 2 away from the y-axis. So this shape is that shape reflected. Now, if we take a look at the values of these points, this point here is 2, 1. The x value is 2, the y value is 1. 2, 1. This x value is -2. The y value is still 1. This value is 2, 4. This value is -2, 4. Hope you can see these are a little small. Let's see if I can zoom in a little bit for you. Zoom in. Yeah, there we go. Okay. Zoom in and focus. All right. This value over here is an x value of 4 and a y value of 1. This value over here is an x value of -4 and 1. So you can see what happens when we flip over the y-axis. When we flip over the y-axis, we wind up getting the negative value of x, the opposite value of x, but we keep the value of y. Right. Now we also could take this original figure and flip it over the x-axis. That means this point would come down here. This point would come down here, still 1 away from the x-axis, but opposite it. And this point would have to come all the way down. This is 1, 2, 3, 4. We'd have to go 1, 2, 3, 4 here, and we could draw our triangle. Now, this point is 2, -1. Now notice here, instead of our x value becoming negative the way it did over here, our y value has become negative. Here we have 4, -1, and here we have 2, -4. So in each case, when we flip over the x-axis, our y values change from positive to negative. When we flip over the y-axis, our x values change from positive to negative. Now you may be asked to flip over some other line as well, but those are two common situations, reflecting over the y-axis, reflecting over the x-axis.